Welcome back to the Deep Dive. Today, we're tearing into something big, potentially transformative for the U.S. energy landscape. Our mission, to really get under the hood of Fermi America's SEC filing. They're a development stage company, and they're proposing Project Matador, this, well, absolutely colossal energy and data center campus down in Amarillo, Texas.
That's right.
Okay, so let's try and unpack this. The basic idea, the driver here, seems pretty simple. AI is just exploding, right? And it's hitting an infrastructure wall. That wall is power. So Fermi's answer, and it's audacious, is to build up to 11 gigawatts of total generation capacity by 2038.
Yeah.
Basically to solve that tower bottleneck.
And what's really interesting, I think, is the structure. It's not your typical tech IPO, not at all.
Right.
It's an infrastructure play, sure, but it's structured as a real estate investment trust.
Okay.
So they're trying to blend this massive long-term energy development project with, real estate exposure, aiming for those passive income streams that REITs need.
So you've got this huge potential, 11 gigawatts is staggering, but
Running
then
this baby.
for the risk.
Oh, yeah. The execution risks are monumental. And to their credit, or maybe necessity, they lay a lot of them out quite clearly in the prospectus itself. We absolutely have to assess that balance.
Let's start with the potential then. Why is this plan grabbing headlines? Because the strategy for dealing with the power problem, well, it seems genuinely clever on paper. They're planning this behind-the-meter private grid right there on campus.
Yeah, that's the core concept.
So for you listening, behind the meter just means they generate the power and use it before it even hits the public grid. They're building this whole vertical ecosystem.
Right. Combining nuclear, gas, solar, and battery storage, BES.
And the whole point is to sidestep the big headaches holding back competitors. The grid congestion, the incredibly slow interconnection queues with existing utility.
Exactly. That time-to-power advantage, if they can deliver, is potentially huge. It could be the ultimate differentiator.
And the anchor for that, long-term at least, is nuclear.
Yes. They're going for a first-mover advantage here, positioning themselves, essentially, as the provider of new nuclear power specifically for AI data centers in the U.S.
So they filed that CLA, the Combined Operating License application, with the NRC back on June 17th, 2025.
Right, for 4 Westinghouse AP1000 reactors. That's targeting 4.0 gigawatts of capacity just from nuclear.
Filing for 4 units at once? I mean, that's a massive regulatory bet. The biggest the U.S. has seen in, what, a decade?
Easily. And you see the political push behind it, too. Getting Rick Perry involved, former energy secretary, former Texas governor, that brings serious weight.
Decades of executive experience, knows energy policy inside out.
Absolutely critical for navigating the regulatory maze they're facing. And Perry himself framed it starkly, didn't he? Highlighting China building 22 reactors while the U.S. has, well, none currently under construction.
So there's this strategic urgency argument.
Right. That political alignment is crucial if they want to hit anywhere near the speeds they're talking about.
And that speed, especially the near-term plan, that seems like the most critical piece of this filing for investors right now. They're promising rapid power delivery.
Very rapid. Phase 1 is targeting 1 gigawatt of operational power plus 1 million square feet of data center space by the end of 2026. That's aggressive.
And that target relies heavily on an asset they picked up in the Firebird acquisition, right?
Yeah.
July 29th, 2025.
Exactly. That fully fabricated 400 megawatt Siemens combined cycle gas system. That's the key. They expect to get that energized by April 2026. That's their beachhead, their entry point into generating revenue.
Okay. But now, the reality check.
Yes. Here's where, from an investor's viewpoint, it gets really interesting and maybe a bit scary. That rapid timeline, it seems almost immediately contradicted by their own disclosures.
How so?
Well, first off, the basics. Fermi is a development stage company. They have no operating history, no historical revenue, 0 operational data.
Nothing to track yet.
Nothing. So they face execution risk across, and this is important, every single major component of this massive plan.
It's that classic chicken and egg situation, isn't it? Need money to build, need customers signed up to get the serious money.
Precisely. And the filing is very clear. Starting phase 1 construction, hitting that 1 gigawatt target requires getting a notice to proceed. And a key condition for that notice.
Let me guess. A signed customer contract.
Executing a binding definitive agreement with a hyperscaler tenant. They haven't got that anchor tenant locked in yet. That's a major condition precedent that's still outstanding.
Okay, so that feeds directly into the financial pressures you mentioned.
Immense pressure. Phase 0 and 1 alone. Expected cost is $2 billion. They need significant additional capital.
Wow.
And the immediate heat comes from that $100 million Macquarie term loan they drew down on August 29th, 2025.
Right. Tell us about the deadline tied to that loan again, because that sounds like a real pressure cooker.
It absolutely is. The loan agreement has this very demanding clause. If Fermi fails to sign at least one 100-megawatt data center lease within 9 months of closing that loan.
9 months from August 29th, 2025. So that puts the deadline around, what, late May 2026?
Exactly. Late spring 2026. If they miss that deadline, the lender, Macquarie, has the right to demand redemption of 25% of the outstanding loan balance.
$25 million, potentially.
Potentially. It's a hard, near-term, very material financial trigger, and it's tied directly to getting that first big customer signed. If they miss it, their whole liquidity picture could change overnight.
Okay, that puts incredible pressure on management to land a major client, like now.
Within months, yeah.
And beyond the immediate cash crunch, there's the long-term nuclear piece. That introduces a whole different scale of risk, doesn't it? They're estimating a 5-year construction cycle for the first reactor.
An aggressive 5-year cycle, starting construction supposedly by the end of 2026.
5 years. I mean, you look at the history in the U.S., Vogtle in Georgia took roughly 15 years, right?
That's the benchmark everyone points to, yeah.
So is 5 years really aggressive, or is it, well, kind of a fantasy cooked up for the prospectus? What makes them think they can do it that fast?
It's spectacularly optimistic, let's say.
Yeah.
They're banking heavily on two things, based on the filing. First, the AP1000 reactor design is standardized and has been built elsewhere, which should simplify things compared to, say, a first-of-a-kind design.
Okay, standardization helps. What's the second factor?
The big one, expedited NRC approval. Their entire timeline hinges on getting fast-tracked licensing from the Nuclear Regulatory Commission.
And that depends on?
Temporary presidential executive orders aimed at speeding up the process. If the political winds shift, or those orders expire or get challenged, well, those timelines could stretch out dramatically, years, potentially.
So they're basically betting the farm on regulatory goodwill and speed.
It's a huge bet on regulatory exception, yes. And then there's the competition. We have to talk about the competition.
Right, because Fermi is building everything from scratch.
While the established tech giants, the potential customers, are already making big moves to secure power now.
And these are the same companies Fermi needs as tenants, right? Competing with your own customers.
Exactly. Look at Microsoft, look at Meta. They've already signed long-term binding power purchase agreements, PPAs, for power from existing or restarting nuclear plants.
Okay, give us the numbers again.
Microsoft secured 835 megawatts from 3 Mile Island. Meta got 1.1 gigawatts from the Clinton nuclear plant in Illinois. They have a massive head start using power sources that are already operational, not projects still on the drawing board.
And Google.
Google's diversifying like crazy. They've got deals for 247 clean power, including advanced nuclear 50 megawatts from Kairos Power via TVA, potentially scaling up to 500 megawatts, plus that huge $3 billion hydro deal for 670 megawatts.
And then there's Stargate.
Can't forget Stargate, the OpenAI, Oracle, SoftBank consortium. They're planning up to 10 gigawatts of AI infrastructure, and they're building sites right there in Texas, too, including Abilene.
So Fermi is jumping into a very crowded pool in its own backyard against giants with deep pockets and existing infrastructure.
It's intense, no question.
Okay, we've sketched out the big picture, the huge potential, the equally huge risks. Now, let's drill down into the specifics an investor really needs to understand. Let's shift into that detailed Q&A analysis.
Okay, let's trace the critical path.
Q1. Lay out the core timeline for us again. What are the key milestones and those immediate make-or-break deadlines?
Right. So the pace has been, frankly, breakneck since early 2025. Company inception, January 10th, 2025.
Okay.
Then a critical step. May 14th, 2025, they nail down that 99-year ground lease with the Texas Tech University system. That's for the massive 5,769-acre site.
Got the land, then the regulatory move.
Yep. June 17th, 2025, they file the CLA with the NRC for the 4 Westinghouse reactors. The big nuclear bet is placed.
So land secured, regulatory process initiated mid-year. What about the actual hardware for generating near-term power, the gas turbine?
That came soon after. July 29, 2025, they closed the Firebird acquisition. That secures the crucial 400-megawatt Siemens combined cycle system, which they emphasize is fully fabricated and ready for assembly.
Okay, hardware acquired, then the money.
August 29, 2025. They draw that first $100 million tranche from the Macquarie term loan.
And that starts the clock. That 9-month countdown to secure the first 100-megawatt lease ending late May 2026.
That clock is ticking right now. Absolutely. So the immediate focus is hitting the December 2025 target for completing Phase 0. That means getting essential external infrastructure ready, securing water services from Amarillo, site prep.
All leading up to.
All leading up to the April 2026 target for energizing that 400-megawatt gas turbine. That turbine has to come online on schedule. It's crucial for generating initial revenue and, just as importantly, proving they can actually execute.
Okay, Q2. Let's talk management and co-founder risk. You mentioned the team looks strong on the energy and nuclear side.
Yeah, the expertise there is definitely a strategic plus. You've got Governor Perry for the high-level policy and connections. Larry Kellerman, Chief Power Officer, has, a 40-year career in power generation. Goldman Sachs, El Paso Corp.
Impressive resume.
And critically, Mesut Uzman, the Chief Nuclear Construction Officer. He led the successful build-out of the huge 5.6 gigawatt Baraka nuclear plant in the UAE, worked on a dozen units in China. This team knows how to build power plants.
But there's always a but in these filings.
Well, yeah. The concentration of expertise is also a risk, and the company's own filing flags potential issues around the CEO, Toby Neubauer.
Right. You mentioned ongoing legal proceedings.
Yes, the Anima Glorify proceedings. The filing explicitly notes these could attract negative press attention. And perhaps more critically for the project itself, could divert management's attention from the day-to-day focus needed to pull off something this complex and fast-paced.
That's a serious distraction risk given how tight their timelines are.
It is. On the other hand, they do have a potential advantage in staffing, geographically speaking.
How so?
The site, Project Matador, is right next door to the Department of Energy's Pantex plant.
The main U.S. nuclear weapons facility.
Exactly, and Fermi specifically points this out in the filing, saying this gives them access to an established local workforce of 4,600 skilled nuclear professionals. That's a significant talent tool right there, mitigates some labor risk.
Interesting synergy. Okay, Q3. Environmental constraints. Big one in West Texas is always water, right? Especially for a project this size, nearly 5,800 acres.
Absolutely. Water use is a major local concern. The High Plains aquifer is under stress, and the scale here is significant. They're projecting using up to 2.5 million gallons per day, or MGD initially.
Growing to
Potentially 5.5 MGD as the complex expands. That's a lot of water.
So how are they addressing that?
Well, they're actively negotiating with the city of Amarillo for a water supply agreement. The plan seems to be to leverage municipal gray water supplies, which is treated wastewater. That would obviously ease the strain on freshwater resources.
Using gray water makes sense politically and environmentally, rather than just pumping fresh groundwater.
That seems to be the primary strategy. But they're also building in redundancy. They hold a groundwater lease via Texas Tech for dual aquifer rights, both fresh and saltwater, giving them a backup source if needed.
And technology. Any water efficiency claims.
Yes, the prospectus mentions using advanced cooling systems, specifically a hybrid dry adiabatic cooling system, which they claim can cut both energy and water consumption by about half compared to typical data center cooling. Efficiency is key to managing that water footprint.
Okay, last question, Q4. This is the bottom line for a potential investor looking at this today. Based on everything, the potential, the risks, the timeline, what are the 5 absolute must-ask strategic questions for Fermi's management?
Right. We need to cut through the optimism and focus on execution certainty. Here's what I'd want answers on. 1, anchor tenant certainty. That Macquarie loan trigger is hanging over them. 9 months to get a 100 mil-W lease signed, ending late May 2026. So the question is blunt. When specifically will Fermi secure that necessary binding hyperscaler lease? Missing that deadline creates immediate financial pain. It's non-negotiable.
Absolutely critical. What's number 2?
2, AI obsolescence mitigation. The full nuclear build-out stretches to 2038. That's a long time in the tech world. How are they hedging against the risk of new AI models like we're seeing from DeepSeek and others that might do complex tasks using drastically less computing power?
Meaning less demand for energy.
Exactly. If AI efficiency jumps significantly, does their multi-decade, multi-gigawatt power plant become oversized for the actual long-term demand? How are they building in flexibility against that technological risk?
Good point. 3.
3, REIT compliance strategy. Remember, they're structured as a REIT. That requires 95% of their gross income to be passive real estate-related income. How precisely will they ensure they continuously meet that test, especially when a lot of their revenue seems tied to generating and selling power, which isn't typically passive rental income? The structural integrity of the REIT depends on this.
Tax, status, investor appeal, all tied to that. Okay, 4.
4. Supply chain dependence. That crucial Siemens gas turbine system. The components are currently warehoused across Germany, Sweden, Vietnam, and China. What is their concrete, guaranteed plan B if geopolitical issues, tariffs, or just plain shipping snafus disrupt that supply chain? Missing the April 2026 energization target for that turbine would be a major blow.
Need a mitigation plan for that. And finally, number 5.
5. Matrix effectiveness. They talk up their proprietary AI project management system, Matrix. Okay, fine. But how does it specifically translate into measurable results? How does it demonstrably reduce the time, cost, and risk on huge projects like this, especially nuclear, which are notorious for delays and budget overruns? We need more than buzzwords. We need proof points or clear metrics showing how Matrix makes a difference.
Okay, those are definitely tough, necessary questions.
Look, the bottom line is this is an incredibly high-reward scenario if they pull it off. But, and it's a big but, it's absolutely constrained by execution hurdles on a scale we rarely see, plus all those financial and regulatory risks they've detailed themselves.
So, summing it all up, what does this mean for the future of powering AI? Project Matador's success feels like this massive, almost generational bet.
It really does.
It all comes down to whether this experienced team can actually convert the political momentum and the equipment they've bought into paying customers, and crucially, those timely regulatory approvals for the first new U.S. nuclear reactors in decades.
It's a race. Against the clock, against deep-pocketed competitors, and against the sheer staggering complexity of building nuclear power plants on an aggressive schedule.
Right. So here's the final thought we want to leave you with today. We heard Meta's head of clean tech innovation point out recently that the most efficient megawatt hour is the one you never actually consume.
Efficiency first.
So if the efficiency gains from next-gen AI, from advanced cooling, from just optimizing compute, if those gains start to outpace Fermi's ability to bring these new gigawatts online between now and 2038, could Project Matador end up being this incredibly impressive multi-billion-dollar solution to a power crisis that maybe has already started solving itself in other ways?
That's the multi-billion-dollar question, isn't it?
Something to definitely mull over as you look deeper into this file, and thanks for joining us on the Deep Dive.